Welcome, scientific investigators. Today, we're going to crack one of the most fundamental cases in all of chemistry, the world of elements. Seriously, everything around us, from the phone in your hand to the very air you're breathing, is made of them. Our mission? To figure out the rules that separate them into two very distinct groups, the metals and the nonmetals.
So what's at the heart of this mystery? I mean, when you look at a piece of iron and then a lump of coal, they seem completely different, right? But what are the specific, observable clues that led a scientist definitively say, yep, this one's a metal, and nope, that one's not? That's the exact question we're going to answer today.
You know, every good investigation needs solid evidence, and our primary source is right here, Chapter 3 of the science textbook. We're going to follow the clues laid out in these pages, breaking down all the key activities and facts to build our case, piece by piece.
Okay, so here's our game plan. First, we'll figure out what makes a metal, well, a metal. Then we'll run through a whole checklist of properties to build a profile. After that, we'll bring in the nonmetals to see how they compare, look at some really fascinating rule breakers, and finally, see where all this physical evidence is pointing us next.
All right, let's get started with our prime suspect. What exactly are the defining features that make an element a metal? The simplest way, the most straightforward way to start grouping them, is just by comparing their physical properties.
Now for the really fun part. The tests. Think of this as our forensic checklist, okay? We're going to run through the key physical properties that, when you put them all together, create the definitive profile of a typical metal.
First up on our checklist is luster, and really, this is just the scientific term for that classic shine you see on metals. When they're in their pure state, metals are naturally reflective and glossy. It's honestly one of their most immediate and recognizable traits.
So how do we prove this? Well, the source text gives us a super simple experiment. You might look at an old rusty ironel and think it's just dull. But, like Activity 3.1 suggests, if you just take some sandpaper and rub away that outer layer of tarnish, bam! You reveal that brilliant, shining surface underneath. Case closed on test number 1.
Next on the checklist, hardness. I mean, you can't just crumble a piece of steel in your hand, can you? Metals are typically tough. They resist being scratched or dented. And while, yeah, some are harder than others, this general sturdiness is a key metallic property.
Okay, next up is malleability. This is an incredible property. It means you can hammer a metal into a super thin sheet without it shattering. Just think of aluminum foil. It's possible because the atoms in metals are arranged in these layers that can actually slide over one another without breaking apart. Gold and silver, they're the absolute champions of malleability, which is why they're perfect for jewelry.
And closely related to this is ductility. That's the ability to be drawn into thin wires. And get this, our source material has an absolutely mind-blowing fact about it. A single gram of gold, just 1 gram, can be stretched into a wire that's 2 kilometers long. That is just astonishing, and it's a huge reason why metals are so incredibly useful in pretty much everything from construction to electronics.
Our next test looks at heat conductivity. As this diagram from our source shows, if you heat one end of a metal rod, that heat travels super quickly to the other end. Why? Well, it's because metals have what's called a sea of free-moving electrons that act like tiny messengers, just rapidly passing that heat energy all the way down the line. It's exactly why cooking pans are made of metal, to get the heat from the stove to your food fast.
And guess what? Those exact same free electrons also make metals excellent conductors of electricity. This classic circuit diagram shows it perfectly. When you place a piece of metal in the gap, those electrons flow freely, which completes the circuit and lights up the bulb. This is the fundamental reason why all our electrical wires are made of metals like copper.
And our final physical property is being sonorous. It's a bit of a fancy word, but it just means that metals make a ringing sound when you hit them. The most perfect, everyday example? A school bell. That distinct resonant clang is a classic signature of a metal.
Okay, so we've built a really strong profile for what a metal is. But you know, a good investigator always has to look at the counter-evidence. To really understand what a metal is, we also need to understand what it is not. So let's bring in the other group, the nonmetals.
This chart just makes the contrast crystal clear, doesn't it? Nonmetals are pretty much the opposite of metals in almost every physical way. They're typically dull, they're generally soft, and if you try to hammer one, it'll just shatter. It's brittle. This is all because their electrons are held really tightly in place, so they can't conduct heat or electricity very well at all.
So, the lines seem pretty clear, right? You've got metals on one side, nonmetals on the other. But hey, this is science, and it is full of plot twists. Not every element plays by the rules we've set out.
So let's look at some of the fascinating exceptions that totally challenge our simple classifications.
Now you have to check out these rule breakers. We said metals are solid, right? Well, boom, here's mercury, a liquid. We said they have high melting points, but you could melt gallium and cesium right in the palm of your hand. And on the flip side, we said nonmetals are dull, but then there's iodine, a nonmetal that's actually lustrous and shiny. And don't even get me started on carbon. As a nonmetal, it can exist as diamond, the hardest substance on Earth, and as graphite, which actually conducts electricity. These exceptions show us that the rules aren't always so black and white.
So, after looking at all this evidence, where does that leave us? We've established a really solid set of rules based on physical properties, but we've also found that a lot of elements just refuse to fit neatly into our little boxes. And that tells us one thing for sure: our investigation isn't over yet.
This brings us to a really crucial question. We spend this entire time classifying elements based on how they look, how they feel, and how they behave physically. But what if the deeper, more definitive clues aren't in their appearance at all, but in their chemical behavior?
And that brings us to our key takeaway. The physical properties checklist is a fantastic starting point. It really is. But it's only half the story. To truly and definitively solve the case of what separates metals from nonmetals, we need to investigate their chemical properties, how they react with other elements like oxygen, water, and acids.
So our investigation into physical properties is closed for now, but the case is far from over. To dig into the chemical properties and absolutely ace your Class 10 exams, make sure you don't miss our next explainer. For more crystal clear breakdowns just like this one, go ahead and hit that subscribe button for the A1 Institute YouTube channel. Thanks for joining the investigation.